This video is going to look at the final product for vectors in 3 space. We looked at the example of having the dot product where the answer was a scalar, and then we looked at the cross product where the answer was a vector, and now we're looking at something called the triple scalar product. And this is where we're actually going to look at multiplying 3 vectors, where we have one vector u dot the product with v cross w. So here we're looking at the cross product of our two vectors v and w, and then we're going to take the dot product with u. Now we could certainly do that step by step. We could find the cross product and then we could find the dot product. But there's a little bit of a shortcut which simply says we need to find the determinant of the 3 by 3 matrix that is made up of the 3 vectors. So u, we could simply take u1, u2, and u3, and then the next one would be v1, v2, v3, and then w1, w2, and w3. So if we find the determinant of the 3 vectors here of this matrix, then we would end up with what's called the triple scalar product. Now, if we take this a step further and we were actually to find the absolute value of the triple scalar product, then we can use this to find the volume of a parallelepiped. And basically what that is, we're looking at whether it's a cube or it could be a cube that where the sides are slanted. They don't have to necessarily form right angles. So let's see if I can sketch out what we're talking about here. So if we have our axis here, and let's say that we have our 3 vectors, u, v, and w. So if I have one vector, let's say going kind of here in this direction, and one is going back here, and let's say the other vector is running along the axis here. So there's our 3 vectors, and if they make up the edges of our parallelepiped, then we're going to kind of have like a cube shape. So that means this would continue back here, and then we could come down. This side would continue over. We could continue out here, and if we went up, this side would come across over here, across the back, and then down here at the front. So here we kind of have a cube, but notice the angles don't have to be at right angles. So if this was our vector here, u, v, and w, if these vectors are representing the edges here of this particular parallelepiped, then we can find the volume by using this triple scalar product. So once we find the determinant, we know the answer, we get an answer that is some number. Well, that number could be positive or negative, but because if we're looking for the volume, all we have to do here is simply take the absolute value of that number if we're trying to find the volume. So let's look at an example. If we're given 3 vectors that represent the edges of one of these parallelepipeds, then we would have u equals I plus j plus 3k, v is equal to 3j plus 3k, and our third vector w, we'll call that, is 3i plus 3k. So if we're going to use this triple scalar product, if we want to find, now I'm not going to try to sketch this out, but if these 3 vectors are representing the edges here of this shape, this parallelepiped, then we could certainly find the volume by using this triple scalar product. So we would take u dot v cross w. And to set this up, we're going to find the determinant here. So our first vector is 1, 1, 3. So that's going to be the first row, 1, 1, 3. And then the next row, notice here for v, there is no I, so that's 0i. So we would have 0 here, and then we have 3j and 3k, so that would be 3, 3. Then we have a 3i for the last one, so that's 3. And notice there's no j, so that would be 0j. And then the last, we have a 3k, so the last row is 303. So now all we have to do is actually calculate the determinant, and this is the same way we did the determinant for the cross product, except for now instead of this top row being I, j, and k, we have the numbers 1, 1, and 3. So once again, we're going to start out with looking at the 1 here. So if we cross out the row and the column, we're left with 3303. And instead of multiplying by I, we're going to multiply by the 1. And then we'll remember it's minus, okay? And then we're going to look at this 1, cross out the row and the column, and we're left with 0333. And again, that's going to be multiplied by our number that we have up here, which is the 1. And then for the last one, it's going to be plus, and we have the 3 here. So again, we cross out that row and the column, and we're left with 0330. And of course, that's multiplied by the number that we have here, which is 3. So now all we have left to do is to find the determinant of each of the 2 by 2's. So if we start that, we would use the cross product. 3 times 3, which is 9, minus 0 times 3 is 0. And of course, we're multiplying that by the 1. And then we have our minus sign. 0 times 3 is 0 minus 3 times 3, which is 9. And again, that's multiplied by the number out front, which is 1. Plus, the cross product here is going to be 0 times 0 is 0, minus 3 times 3, which is 9. And we have the number 3 out front. So if we simplify each one of these, we would end up with 9 minus 0 times 1, which is 9. We have the minus sign here we don't want to forget. But then negative 9 times 1, so we have a negative 9 with a negative out front, so that's going to make this a positive 9. And then we have plus 0 minus 9, so that's a negative 9 times 3, which would be a negative 27. And we can see here that we would get 18 minus 27, which this would be equal to a negative 9. But remember, we need to find the absolute value to find the volume. So the absolute value of this would be equal to a positive 9. And then this would be 9 cubic units. So whatever the units are, it'd be your units cubed. So here is the volume of whatever this parallelepiped shape that we have given these 3 vectors as the edges. Now this one's a little bit different. We can do this by hand fairly easily. Now because the cross product, this first row was I, j, and k, we couldn't use the calculator. Because we have numbers here, we could certainly use the calculator to come up with the negative 9. All we have to do is find the determinant of this 3 by 3 matrix. So if we go to the calculator, we're going to go to second function and this x to the negative 1 here where it says matrix, and we're going to go scroll over with your arrow key to highlight edit, and I want to select number 1, which is A. And we have, if we look at our matrix, remember this is a 3 by 3 matrix, so instead of 2 by 2 we would type in 3 enter 3 enter. So now we have where we can enter 3 rows and 3 columns. So we want to enter in now the 113, 033, and 303. So we're going to go across 1 enter, 1 enter, 3 enter. So there's the first one. And if we go to the second vector, it would be 0 enter, 3 enter, 3 enter. And then we would have 3, 0, and 3. Now when I type in the last one here, make sure you hit enter so it shows up here at the last entry. So when I hit enter, it shows up 303 for the last row. Now to make sure that we exit out of this edit mode, the only way I know how to do that is hit second mode, which is quit, and it takes you back to the home screen. But now we want to go back into the matrix, so second function in matrix. we want to scroll over to math, and number one is DET, which stands for determinant. So we're going to select number one, and we want to take the determinant of our matrix. So we'll go back into the matrix one more time, and then simply select one, or wherever you put the matrix. Well, mine was under A, so I'm going to select one, close the parentheses. So we're going to take the determinant of matrix A, and we should get an answer of -9. And that's what we ended up with here. But remember, we wanted to take the absolute value because remember, we were actually calculating the volume. So if you're looking for the volume, you would take the absolute value. If you're not looking for volume, then -9 would be the answer.